This lesson has been developed in the framework of SCILED project. Module 1, Footwear Performance and Comfort. Unit 4, Introduction to Hydrothermal Comfort.
Lecture 4.2. Water Resistance, Absorption and Vapor Permeability or Breathability. This lesson is structured as follows.
Definition. Concept and theory. Role of footwear in water resistance, absorption, vapor permeability or breathability. Comfort requirements addressing water resistance and absorption, vapor, permeability or breathability, recommended values for parameters, and innovative solutions to support water resistance or absorption and vapor permeability or breathability.
Definition, concepts and theory.
Many types of footwear require some degree of water resistance, especially those designed for winter, rain or snow conditions, golf, hiking and some professional activities that involve contact with water or wet conditions. In these situations, materials and footwear models shall be selected and conceived to function as a water barrier, avoiding or minimizing the absorption of water and its passage into the inside of the footwear. The absorption of water through materials and footwear will lead to a wet sensation and foot cooling, provoking foot discomfort. There are 3 tests for water resistance on footwear materials and 3 on whole footwear. For materials there is the Bally permeameter test, Meissner water penetration test and water resistance of heavy leather.
Bally penetrometer is applicable to all flexible leathers but is particularly suitable for leathers intended for footwear uppers. In these tests a piece is formed into the shape of a trough and flexed whilst partially immersed in water. The time taken for water to penetrate through the test piece is measured. The methods also allow the percentage mass of water absorbed and the mass of water transmitted through the test piece to be determined. The Bally permeameter testing methods are described in ISO 17702, Footwear, Test Methods for Uppers, Water Resistance and ISO 20344, Personal Protective Footwear, Footwear Test Methods.
The Meissner water penetration test is more stringent than the Bally penetrometer test. This test covers the determination of the dynamic water resistance of shoe upper leather and is applicable to all types of shoe upper leather. The flex imparted to the leather is similar to the flex made by the vamp of the shoe in actual wear. The standard testing method for the Meissner water penetration test is described in ASTM D2099. Standard test method for dynamic water resistance of shoe upper leather by the Meissner water penetration tester.
The water resistance of heavy leather test method is applicable to soles made of leather. The test piece is continuously wet on one surface and is flexed and compressed in the same manner as the sole of a shoe during walking. This enables various aspects of heavy leather water resistance to be measured with respect to time. The standard testing method is described in ISO 5404, Leather Physical Test Methods, Determination of Water Resistance of Heavy Leathers.
There are 3 tests for the whole footwear: dynamic test, machine scrubbing test and trough test, all described in ISO 20344-2011 Personal Protective Equipment, Test Methods for Footwear. The dynamic test method is used to evaluate the resistance to water penetration of a whole footwear during flexing and can be applied to all types of footwear. Basically, the shoe is secured in a flexing machine with water at a defined level above the feather line. The footwear is flexed at a constant rate and inspected for water penetration. This test is intended to simulate the flexing force performed during the walking movement.
The machine scrubbing test is a complementary test that is based on a machine with brushes and water jets. In this method the whole footwear submerged in a defined depth of water is subjected to the mechanical action of rotating wet brushes. The extent of water penetration is determined by examination. The shoe is fixed in a rectangular metal plate with a fixed jaw at one extremity and a sliding jaw at the other to adjust to the height of shoe. Then 2 brushes situated on either side of the test piece are separated by adjusting a distance describing a backwards and forwards motion over the whole length of the test piece, whatever its size. The horizontal motion of each brush is completed by a rotational movement, the direction of which changes at the end of each horizontal cycle. The direction of rotation of each brush is the same as the corresponding backwards or forwards motion. The horizontal distance between the 2 brushes system should be adjusted so that the whole surface of the footwear upper touches the bristles. This test method is useful to evaluate if the shoe just has a superficial water repellence treatment. The passage of the brushes will remove the superficial treatment and evaluate effectively the water resistance of the shoe.
The trough test allows the determination of the water resistance of footwear, irrespective of the material. In this test, a pair of footwear is worn whilst a measured number of paces are walked over a surface flooded with water to a measured depth. The extent of water entry is determined by inspection. After 100 trough lengths, the footwear is carefully removed, and the inside is examined visually and by touch for signs of water penetration. If any penetration has occurred, the position and extension should be recorded on diagrams for each boot or shoe. Water absorption and desorption are related to the material capacity to absorb and release water. These properties are important for removing sweat from the foot skin surface and minimizing the wet sensation and foot cooling due to the accumulation of humidity inside the footwear. Permeability. Breathability. The sweat is a mechanism used by the body to regulate the skin surface temperature. In hot conditions or during physical activity, the body releases sweat to decrease the skin temperature. However, the accumulation of sweat inside footwear is responsible for foot discomfort due to the wet sensation followed by cooling of the feet, principally when the subjects are physically inactive and the heat released by the feet decreases. The breathability of materials is related to their capacity in the passage and absorption of water vapor. This phenomenon reduces the humidity by avoiding its accumulation inside the footwear, thereby minimizing the wet sensation and cooling of feet. The accumulation of humidity of materials can also reduce their thermal insulation, because water is a much better thermal conductor when compared with air. Insulating properties. During the selection of materials for footwear, it's important to evaluate their breathability, that is, the capacity to transfer/transmit the humidity from the inside to the outside of the shoe. The type of bonding is also important because the glue might compromise the breathability of the materials.
The studies available in the literature indicates that in a warm environmental foot may sweat between 30 grams per hour to 50 grams per hour. In cold conditions and heavy exercise, the sweat rate is about 10 grams per hour per foot. The sweat rate in average can change from 3 grams per hour during resting period to 15 grams per hour during high-level exercise. Some literature recommends relative humidity in the feet around 60%. However, frequently this value reaches near 100%.
The moisture can be transported out of the shoe as seen in the figure. 1. From skin through the sock through the footwear material. 2. From skin through socks along inside of the footwear. 3. Along the inside of the sock. In the process of developing a new shoe, it's important to consider the properties of materials and conceive models that promote the elimination that is inside of the shoe. For example, by using breathable materials and ensuring a good ventilation inside the footwear.
Water vapor absorption is the amount of vapor a material will absorb in a specified time expressed as mass of water per area of material. To evaluate the water vapor absorption capacity, the footwear materials are placed enclosed inside a metal container with water during the duration of tests. Water absorption of the test piece is determined by its difference in mass before and after the test. The standards ISO 20344-6.6 and ISO 17699 describe methods to evaluate the water vapor permeability of lining and upper materials. Water vapor permeability is defined as the amount of water vapor a material will transmit through its structure expressed as mass of water transmitted per area of material per hour. In this method, the test piece is fixed over the opening of a jar, which contains a quantity of solid desiccant. This unit is placed in a strong current of air in a conditioned atmosphere. Then, the air inside the container is constantly agitated by the desiccant, which is kept in movement by the rotation of the jar. The jar is weighed in order to determine the mass of the moisture that has passed through the test piece and has been absorbed by the desiccant.
Role of footwear on water resistance, absorption, vapor and permeability. Breathability.
To produce a breathable and water-resistant or waterproof shoe, it is fundamental to act in the selection of materials, design and production process. For that, several factors shall be taken into consideration, namely,
upper and lining materials should be water-resistant and breathable, soles should be water-resistant, insocks should be breathable, and the construction design should be made in such way that does not allow the penetration of water, especially in the interface of the various components. A good example is the interface between the sole and the upper. Usually a shoe that is waterproof and breathable features a membrane that is permeable to water vapor but does not allow the penetration of water droplets. Some examples of footwear that uses this technology will be shown in the last section of this lecture. To keep the feet comfortable, footwear materials should have a certain capacity to absorb the moisture, removing the humidity from the feet surface. The materials should also be breathable to allow the humidity to be transferred to the outside of the footwear, keeping the foot dry. The use of impermeable materials, that avoid the elimination of moisture outside of footwear, is also a factor that contributes to accumulation of humidity inside of the footwear and cool the feet down, resulting in a discomfort. The following 3 slides present the recommended values for water resistance, absorption, vapor, and permeability.
There are recommended values for valley permeability for casual footwear and for occupational footwear.
The recommended values for casual footwear are as follows. Footwear is considered water resistant if penetration time is greater than or equal to 60 minutes, where the absorption after 60 minutes is 20% or less. The footwear is highly water resistant if penetration time is greater than or equal to 180 minutes, the absorption after 180 minutes is 25% or less. In the case of occupational footwear, the water penetration after 60 minutes shall be 0.2 grams or less and the water absorption 30% or less. The recommended values for the mice or water penetration are divided in 3 categories according to the resistance. Medium resistance for 1000 to 5000 flexing cycles, good resistance for 5001 to 10001 flexing cycles, excellent resistance for higher than 10,001 flexing cycles. Regarding the water resistance of heavy leather, the recommended values are as follows. A leather is considered water resistant if for a penetration time higher or equal to 30 minutes the water absorption after 30 minutes is 25% or less. And is it considered highly water resistant if for a penetration time equal or higher than 60 minutes the water absorption after 60 minutes is 15% or less. Dynamic test. The total wet area inside footwear shall be less than 3 squared centimeter of water penetration after 100 trough lengths. Machine scrubbing test. Total wet inside footwear shall be less than 3 squared centimeter of water penetration after 80 minutes. Trough test. Water penetration shall not occur before 15 minutes of test. Specifications and requirements are given in the following standards. ISO 20345, Personal Protective Equipment. Safety footwear. ISO 20346, Personal Protective Equipment. Protective footwear. ISO 20347, Personal Protective Equipment. Occupational footwear.
Water vapor permeability and absorption. Recommended values for occupational footwear are:
Lining, water vapor permeability higher than 2.0 mg per squared centimeter per hour and water vapor coefficient shall be higher than 20 mg per squared centimeter. Upper, water vapor permeability higher than 0.8 mg per squared centimeter per hour and water vapor coefficient shall be higher than 15 mg per squared centimeter. In the case of casual footwear we have: lining, water vapor permeability greater or equal to 2.0 mg per squared centimeter per hour. If water vapor permeability of upper is less than 0.8 mg per squared centimeter per hour, then water vapor absorption of lining shall be greater or equal to 8.0 mg per squared centimeter. Upper, water vapor permeability higher than 0.8 mg per squared centimeter per hour and water vapor coefficient shall be higher than 15 mg per squared centimeter. Now looking at the water absorption and desorption. The specifications and requirements are described in ISO 20347 for personal protective equipment occupational footwear and ISO TR 20882 for footwear. Performance requirements for components for footwear. Lining and insocks. The recommended values for water vapor permeability are as follows. For occupational footwear, the absorption shall be greater or equal to 70 mg per squared centimeter and the desorption shall be greater or equal to 80%. For casual footwear, the absorption shall be greater or equal to 70 mg per squared centimeter and the desorption shall be greater or equal to 60%.
Innovative solutions to support water resistance, absorption and vapor permeability. Breathability.
Merrell developed technologies that allows the shoe to be waterproof while it lets the inside moisture escape, keeping the feet dry. M-Select Dry and M-Select XDRY. In addition to these two technologies, Merrell also developed the M-Select Fresh that prevents sweat and moisture from affecting the freshness of shoes. This technology is based on antimicrobial agents that penetrate and disrupt the production of odor and microbes. Model Air Antis is the evolution of the perforated rubber outsole. Geox replaced the classic holes with large perforations, a protective mesh, a full-size membrane and a special inner lining with air pockets, to guarantee increased breathability for the feet. At the same time, the outsole is waterproof, thanks to the insertion of a special waterproof and breathable membrane. The true benefit of this system is that it keeps feet dry. Model Waterproof Leather. Geox research has found an innovative way to make a naturally breathable material like leather waterproof. We use a special breathable waterproof membrane inside the leather outsole so the foot stays dry all day long. The true benefit is that you can wear your Geox shoes in any situation, even when it's raining. Geox has created Amphibiox, a totally waterproof shoe that breathes, thanks to a special membrane that extends beyond the outsole, and even to the top part of the upper, to protect the feet in any weather conditions. Model Rubber Outsole. Shoes with a rubber outsole can present breathability issues, therefore Geox perforated the rubber outsole and inserted a special waterproof and breathable membrane inside it, allowing the feet to breathe while preventing water from entering the shoe. The true benefit of this system is that it keeps feet dry. Gore-Tex developed a membrane that is waterproof, windproof and breathable. The membrane itself is extremely thin, about 0.01 mm. To create their product technologies, Gore-Tex bond the membrane to high-performance linings and outer textiles, creating the Gore-Tex laminate. The membrane is porous, and each one of those billions of pores is also 700 times bigger than a water vapor molecule, which means that, when the body temperature rises, the sweat can escape through the pores of the membrane. At the same time, water molecules from rain, for example, cannot penetrate. This makes the membrane waterproof and breathable. The model Ali Navy is one example from to work for. That is water-resistant and breathable. Blue Microfiber, an innovative material made of polyester fibers, water-resistant and highly durable. Allows natural breathing and being an animal-friendly material. Mesh Poromax Lining, a technology with a special structure of internal chambers that removes hot moist air over the top of the shoe and facilitates uniform temperature distribution.